I was just watching a video on a channel I've not seen before called Astrum. And the video is called The 9 Experiments That Will Change Your View of Light and Blow Your Mind. And as I was watching it, it was reviewing the known science about how light is both a wave and a particle, and talking about photons and the experiments that have been run where light is shot through a slot, and whether there's an observer being, it could be the naked eye, it could be a camera, or not. The results will be different, and so on and so forth. And that experiment has always bothered me. Part of what bothers me about it is there's always this statement embedded in this that suggests that the light is alive, that it changes its behavior depending on whether it's being observed or not. And I'm fairly certain this is wrong, but I haven't been able to figure out why, aside from the fact that the light is not sentient. So now the reason that scientists believe that light is a wave is because it displays in the receiving medium on the other side of the slots what is called an interference pattern. And an interference pattern is what happens when two waves collide. And my objection to that is that when we talk about wave interference, we're assuming that light follows the same rules as, say, water or oil. And I don't think it does. So I think that this is a false jump in logic. Now, I'm not a physicist. I'm not a quantum physicist. I'm just sharing my thoughts just to get them out of my head. I think light is photons, and when you shoot an individual photon through one slit, it shows up on the other side. And I think that when you rapidly shoot photons through one slit and then the other, and it creates an interference pattern, there's a reason for it. And I'm at a loss as to clarify how that is happening. Other than that, there's interference of some kind, which really doesn't help at all. But if we look at the next part of the problem with this, which, I mean, to me, the part that bothers me, and I encourage you to watch Astrum's video. I'll try to remember to put the link down below. He was talking about using a polarizing lens and how, depending on how it's turned, some light will be blocked. And he was talking about how if you take 2 or 3, you can actually increase the amount of light that is being perceived. And then he was talking about how if a light wave goes through at an angle instead of horizontally or vertically, if it goes through diagonally, it has a 50-50 chance that it will either turn fully in the direction that's necessary, could be vertical, could be horizontal, in order to get past the polarized lens, or it'll turn in the other direction and be stopped by the lens. Now, I find this really fascinating because a simple solution to that came to mind to me, and I'm probably wrong, but I just want to share this. So if we have a beam of light, and the beam of light hits a barrier, and the barrier is a mirror, for example, then it'll bounce off in the direction that the angle allows it to bounce. So if we have a wave of light, so to speak, going through a polarizing lens or a polarized lens. What could be happening here is that whether it flips to the correct orientation to pass through or the incorrect or the correct orientation to be blocked is dependent on when where the wave intersects that, I guess, chemical barrier in the polarized lens, which is to say, if this is the lens, and this is we just can say my hand is the barrier. If the wave of light is snaking along and it hits it here, then it's going to be blocked because it'll turn the wrong way. But if it snakes along and it hits it over here, then it will be turned the right way and continue on. And I think that's what's happening. I think this is just a simple matter of reflection into the right orientation or the wrong orientation. And this is an oversimplification because I lack the knowledge and vocabulary to be a lot more technical about this. But I think that's what's actually happening. So I don't think that light changes its behavior. I don't think there's anything to do with an observer, live or mechanical, or no observer. I think it's just that scientists don't understand. And rather than admit they don't understand, they come up with this crazy idea that light changes its behavior based on observation. In medicine, when you have an illness or disease that is they can't figure it out, they use the word idiopathic, which means either that the disease arises spontaneously or the cause is unknown. So it's a very fancy way of saying, we're sorry, we really don't know what's causing this problem. And there are several other words in medical terms that are very vague and sound very important. And they're just saying, not sure, in a way that makes people feel like, oh, they know what they're talking about. It's kind of funny, really. Because, doctors have been held up on pedestals for a very long time. And so for them to say, gosh, I'm not really sure, is something that people don't like to hear. They want comfort. They want to know that the doctor can get the upper hand, can solve the problem. And so the doctors apparently came up with these strange words to tell people who know that they don't know. But everybody else is like, oh, I don't really understand, but okay, thank you, doctor. So I'm not saying that doctors necessarily deliberately try to hide the fact that they don't understand. But these words really do mean I don't understand. And I think this is the case with the idea that light changes its behavior based on observation or not. So you may think, but Glenn, if you fire two different photons at two different slots and they make an interference pattern, that makes sense. Well, no, it doesn't make sense, because then you're talking about time travel. Because if I fire, pew, and then I fire, pew, and I get an interference pattern based on the theory of there being waves involved, that means either the first firing traveled into the future, anticipating that I would fire a second time to meet with the second firing and create an interference pattern, or the second pattern traveled into the past, already being aware that his friend was waiting for it back there and made the interference pattern. Occam's razor is not a law. It's just a principle to try to deduce the best explanation for something. But in this case, Occam's razor is right, and it dictates that there's no traveling through time going on. And thus, it's not waves. So I hope that you can see that there's a problem. And just because scientists are grasping at idiopathic straws doesn't mean that their theory is correct. But hey, I could be wrong.